Hello students, myself Professor Ashok M Jain. In this lecture, I am going to discuss about winding resistance. I am going to discuss about the practical transformer, that is actual transformer. We have to consider the winding resistance, the leakage reactance. Then if you want to make the system or if you want to make the calculation simple on paper, so we have to refer the secondary quantities towards the primary side or primary quantities towards the secondary side. That is the referred value, and no load equivalent circuit of transformer, right? So I'm going to discuss about these. Okay, so already we have discussed about ideal transformer. In case of ideal transformer, the winding resistance was 0. Second, the leakage flux was 0. Third, the whatever the flux produced, or if you draw a BH curve, it is a straight line, no saturation, right? So here we are going to consider all these factors. So we are going towards the actual transformer, or it is also called as practical transformer, right? So here, first of all, I'm going to discuss about the winding resistance of transformer, right? So we have one transformer like this. This is the primary winding, and clear, and this is the secondary winding. I'm assuming it is a step down transformer. Primary having more turns, secondary is having less turns. So it is a step down transformer. The voltage induced on the secondary is E2, on primary is E1, clear, and primary winding have resistance of R1 and secondary side having resistance of R2, right? And this is the terminal voltage V2, supply voltage V1. So if I want to discuss this only if we have an actual transformer or practical transformer, winding resistance will be on primary side is R1 and secondary side it is R2. Okay. But in case of ideal transformer, they have given that was the condition that the winding resistance was 0 on primary side and secondary side. Okay, so here when we are going towards the actual transformer or practical transformer, winding resistance will be there R1 and R2 on primary side and secondary side, right? I'm rubbing it. Second case I'm going to consider, that is the leakage reactances. Okay, so if we have a practical transformer, leakage reactances will be there. Means we have studied, this was the transformer, say core type transformer, right? Here it was a LV winding or any one winding primary, and this is the secondary winding we have. Sorry. So when we apply the voltage here, current I1 flows. Okay, this will link with the N1 turns, produce the flux. Okay, and that flux confined or links both primary and secondary. So flux is linking both primary and secondary. Same flux. So as per the ideal transformer, same flux links both primary and secondary. Okay, so EMF induced on the primary E1 and E2 on the secondary side, right? There is no leakage flux. इसका मतलब है there is no leakage flux means what? There is no leakage flux here. इसको बोलते हैं phi L1, leakage flux one primary side and this on the secondary side, right? This is phi L2. So वो बोलता है in case of ideal transformer no leakage flux, phi L1 and phi L2 0. But in active transformer, leakage flux will always be there. You can minimize it by using the sandwich type of winding. You can minimize the leakage flux, but it will not be zero, right? So in actual transformer, leakage, that flux will be diverted to the non-ferromagnetic material. This is the ferromagnetic material. Flux यहाँ से flow होना चाहिए, but it is diverted to the non-ferromagnetic material. इसका मतलब है some flux links with the winding only, or some flux flows to the air also. That is called as leakage flux phi L1 and phi L2. Okay. सो जब ये ड्रॉप हो जाएगा, लीकेज फ्लक्स रहेगा, तो यहाँ ड्रॉप होगा प्राइमरी वाइंडिंग में और सेकेंडरी वाइंडिंग में, राइट? क्लियर? सो वी आर अज्यूमिंग that is the drop on the primary side and secondary side, let us say EL1, and voltage drop on the secondary side EL2, and this drops will lag to the reference voltage or reference flux by angle of 90 degree. These two drops will be there, they will lag to the 90 degree. इसका मतलब है we are assuming to fictitious quantity. fictitious मतलब काल्पनिक values x1 and x2 in such a way that ix1 and ix2 voltage drop is there, and we know voltage drop in pure inductive circuit lags the reference by angle of 90 degree, minus 90 degree, lags by 90 degree. इसका मतलब है we will assume a fictitious value x1 and x2 is there in case of practical transformer. Okay, so in case of practical transformer, we have a reactances are there on the primary side and secondary side, and these are the fictitious values. So you can make a transformer, say step down transformer. These is the reactances are there, x1 on primary side and x2 on the secondary side, right? So in case of actual transformer, we have a resistance and reactance both. We are applying voltage V1, current is flowing I1, produce a flux, and यहाँ पर drop voltage E1 will be induced, and यहाँ secondary side EMF will be induced on the E2, and these are the reactances, x1 on the primary side and x2 on the secondary side. This is the terminal voltage V2. Okay, so in case of practical transformer, both resistance and reactances are there, R1 X1 on the primary side and R2 X2 on the secondary side, right? So this is the reactances. I'm rubbing it. Next, I'm going to talk about the referred values. What is a referred values? Actually, we know in actual transformer how the transformer, you can see here, this is the primary side. Clear? I am assuming it is a step down transformer, so secondary turns are less, right? This is the resistance R1 on primary and X1 on primary, R1 and X1. Clear? Or secondary side it is R2 and X2. These are the resistance on the primary side and reactance on primary side, resistance and reactance on the secondary side. Here it is, we are applying the voltage source, we are applying, that is V1. Clear? I1 will flow, flux will be produced, and that same flux is linking with the secondary side, so EMF induced on the primary E1, and on the secondary side EMF induced on the secondary side E2. This is the terminal voltage V2 and here V1, and you can connect the load here. So R1 X1 on the primary, R2 and X2 on the secondary. But if you want to make the calculation simple, So you can refer secondary quantities towards the primary side or primary quantities towards the secondary side. Clear? So suppose secondary resistance क्या है? Secondary resistance क्या है? R2. If secondary resistance referred to primary side, so this will be called as R2 secondary resistance dash मत लगा दिया मतलब it is referred to primary side. So you can refer the secondary resistance towards the primary side. Secondary reactance referred to primary, इसको क्या बोलेंगे X2 dash. So you can refer the secondary quantities towards the primary side. This will make the calculation simple. In on paper you can do, but actual में ऐसा नहीं होगा कि secondary resistance refer primary side हो गया या primary secondary. Only to make the calculation simple you can refer it. Okay, so it can be do it. So what is the calculation I am going to discuss, right? So since we know V2 upon V1 are equal to E2 upon E1 equal to क्या होता है N2 upon N1 equal to called as transformation ratio K. Okay, equal to what? I1 upon I2 होता है I1 upon I2 equal to K, right? So this is K. So what is the value of V1? V1 equal to what? V2. V1 equal to क्या होगा? V2 upon K. V2 upon K. Let us say V2 मतलब secondary voltage drop. V2 means secondary voltage. Let us say secondary voltage drop. Assume करो V2 क्या होगा? Secondary voltage drop in resistance. क्या होगा भाई? Secondary voltage drop in resistance I2 R2. I2 R2 upon K. So I2 R2 upon K किया तो ये क्या हो जाएगा? V1. V1 मतलब secondary voltage drop referred to primary side. So I had secondary voltage drop that is I2 R2 था, उसको primary side में refer कर दिया तो क्या होगा? That is it. This I2 R2 upon K equal to I2 into R2 upon K. I don't want I2, I want I1. Primary side refer कर रहे primary side में तो I2 के बदले में क्या होगा? I2 equal to क्या होगा? Since from here I2 equal to क्या होगा? I1 upon K. So you can write I1 upon K into R2 upon K equal to I1 primary side into R2 upon K square. This K square. Clear? So equal to I1 into R2 upon K square equal to called as secondary resistance referred to primary side. Clear? So this is called as, इसका मतलब है secondary resistance referred to primary क्या हो जाएगा? R2 upon K square, that is called as R2 dash. Similarly secondary reactance referred to primary क्या हो जाएगा? X2 upon K square equal to X2 dash. Be careful, अगर आपने K ये लिया है N2 upon N1 equal to E2 upon E1 equal to V2 upon V1 equal to K लिया है तो सेकेंडरी से अगर प्राइमरी में रेजिस्टेंस और रिएक्टेंस रेफर कर रहे हैं तो क्या करना है? K स्क्वायर से डिवाइड करना है. Clear? Okay, so this is now, so I got it right. Now equivalent resistance on primary. अभी प्राइमरी क्या है? You can say it is R01. इक्विवेलेंट रेजिस्टेंस मतलब इक्विवेलेंट रेजिस्टेंस लिखा है तो R01. आप अभी you can say प्राइमरी क्या है? हाई वोल्टेज है कि लो वोल्टेज है? हाई वोल्टेज है. तो you can in place of that R01 के बदले में आप ऐसे ले सकते हैं R0H इक्विवेलेंट रेजिस्टेंस ऑन हाई वोल्टेज साइड. बी केयरफुल अबाउट, अगर ऐसा है तो अगर यहाँ इस साइड प्राइमरी साइड में अगर लो वोल्टेज वाइंडिंग होती तो R01 लिखते, फॉरगेट इट. ओके, इक्वल टू क्या है, पहले से कितना है, R1 है, पहले से R1 है, और ये रेजिस्टेंस रेफर करके प्राइमरी में आ गए तो क्या हो जाएगा, R2 डैश, प्राइमरी में रेजिस्टेंस ऑलरेडी R1 है, एंड सेकेंडरी रेजिस्टेंस रेफर टू प्राइमरी क्या होगा, R2 डैश इक्वल टू क्या होगा, ये R1 प्लस R2 अपॉन K स्क्वायर. Similarly, equivalent reactance on primary, that is X01 equal to X0 H है, हाई वोल्टेज साइड है, प्राइमरी साइड इक्वल टू क्या होगा, ऑलरेडी X1 था प्लस X2 डैश इक्वल टू क्या था, X1 प्लस X2 बाई K स्क्वायर, इन दिस वे. Clear? So secondary quantity, if you are referring towards the primary side, you can get it. Now diagram कैसे आएगा, I am just correcting it. मैं इसको रब करता हूँ. Just I am going to do it. प्राइमरी में क्या था, पहले से सप्लाई वोल्टेज V1, यहाँ पर क्या आएगा, R1 था, सेकेंडरी रेजिस्टेंस आएगा R1 प्लस R2 डैश, यहाँ आ गया. सिमिलरली इट वाज X1 था, सेकेंडरी रिएक्टेंस क्या आएगा, X2 डैश, X1 ऑलरेडी था, X2 डैश. क्लियर? That was the primary side. Voltage is E1. Clear? Secondary side में कुछ बचेगा ही नहीं. That is what, I1. और I1 अपॉन I2 इक्वल टू क्या होता है, I1 तो ये है, सो I2 रिफर टू प्राइमरी करेंगे तो क्या आएगा, I2 इंटू K, और व्हाट, I2 डैश सेकेंडरी करंट रिफर टू प्राइमरी साइड इक्वल टू E2 डैश सेकेंडरी वोल्टेज रिफर टू प्राइमरी साइड. सेकेंडरी रिफर कर रहे हैं तो डैश डैश लग जाएगा, याद रखना. सो इट इज द रेफर्ड इक्विवेलेंट सर्किट, यू कैन से. ओके, सो ओके. सिमिलरली अगर आप प्राइमरी क्वांटिटीज को टूवर्ड सेकेंडरी साइड ले जा रहे हैं तो क्या आएगा भाई, R02 इक्विवेलेंट रेजिस्टेंस ऑन सेकेंडरी. और सेकेंडरी साइड में क्या है, लो वोल्टेज वाइंडिंग है कि हाई वोल्टेज वाइंडिंग, नंबर ऑफ टर्न्स कम है तो लो वोल्टेज वाइंडिंग. तो आप चाहो तो इस केस में क्या ले सकते हैं, R0L. सेकेंडरी में क्या था, पहली से क्या था, R2 था, R2 प्राइमरी रेजिस्टेंस R1 उधर जाएगा तो क्या कहलाएगा, R1 डैश प्राइमरी रेजिस्टेंस रेफर टू सेकेंडरी इक्वल टू क्या होगा, R2 प्लस R1, और प्राइमरी रेजिस्टेंस रेफर करेंगे सेकेंडरी में तो क्या होगा, डिवाइड बाई K स्क्वायर, मल्टीप्लाई बाई K स्क्वायर, मल्टीप्लाई बाई K स्क्वायर. याद रखना, प्राइमरी रेजिस्टेंस रेफर टू सेकेंडरी करेंगे तो मल्टीप्लाई करना है. सिमिलरली X02 क्या होगा, X2 प्लस X1 इंटू K स्क्वायर. सो व्हेन यू आर रेफरिंग सेकेंडरी से प्राइमरी में आएगा तो डिवाइड बाई K स्क्वायर होता है, और प्राइमरी से सेकेंडरी में आएगा तो मल्टीप्लाई बाई K स्क्वायर. बी केयरफुल अबाउट इट. So these are the referred value, you can get it. Okay, so please, I have taken it and I have taken this to clear your concept. Okay, now I am rubbing it. Only this you can refer primary to secondary or secondary to primary only to make the calculation simple. You can do it on paper only, not in actual case. Okay, so for will make the calculation simple. Okay, and the last part I am going to discuss, that is the no load equivalent circuit. No load equivalent circuit. What is a no load equivalent circuit? Okay, so at no load, you know, if you see the diagram, we have a no load actual, I'm a practical transformer. प्रैक्टिकल ट्रांसफार्मर मतलब एक्चुअल ट्रांसफार्मर आई एम गोइंग टू टॉक। तो इन एक्चुअल ट्रांसफार्मर नो लोड पे क्या होगा, आई जीरो क्या होता है, आई जीरो इज द वेक्टर सम ऑफ आई सी एंड आई फाई। वी नो दिस इज कॉल्ड एज मैग्नेटाइजिंग करंट, मैग्नेटाइजिंग कंपोनेंट ऑफ करंट। इसका काम क्या है, टू प्रोड्यूस अ फ्लक्स। ये आइडियल में नहीं रहता बट एक्चुअल में रहेगा। ये एक्चुअल इसको क्या बोलते हैं, वाटलेस कंपोनेंट, वाटलेस और एक्टिव कंपोनेंट। ये क्या शो करता है, इट शोज द आयरन लॉस and in case of ideal transformer iron loss is zero, so this component is not there, clear। and if you draw the vector diagram, कैसे बताया था आपको, phi I phi E1 E2, it depends कौन सा है। यहाँ पर E2 ज्यादा बड़ा दिख रहा है मतलब इट स्टेप अप है, ओके, that is V1 dash, okay, this is IC here or that was the I0 and this is phi 0. So please, that is a vector diagram. Now I have to draw the equivalent circuit. So equivalent circuit matlab this is the, we are going to apply the voltage V1, clear। I0 is flowing, no load, at no load, so only I0 will flow, okay। and I0 will have two component, one is in the same phase with the voltage, you can say IC is in the same phase with the voltage, so IC and I phi, you can say IC and I phi, दो component I0 को, and IC कहाँ है, same phase with the voltage, and we know voltage and current are in the same phase कब होते हैं, जब ये करंट कहाँ फ्लो हो रहा, प्योरली रेजिस्टेंस में, तो IC is flowing in the purely रेजिस्टेंस से RC, and you can say I phi is lagging to the voltage by angle of 90 degree, I phi is lagging to the voltage, and we know, we have studied in basic electrical engineering or in 11th 12th, current lags the voltage by 90 degree। कब lag करता है, जब ये purely inductive में हो। So this is the current flowing through purely inductive circuit, okay। So this is X phi and RC, clear। So be careful about it, these RC and X phi are called as exciting branches, exciting resistance and exciting reactance, okay। This shows the core loss resistance actually, okay। So और ये यहाँ यहाँ पर क्या रहेगा, प्राइमरी साइड, और दिस इज ऑन द सेकेंडरी साइड, दिस इज E2, दिस इज E1, क्लियर। एंड टर्मिनल पे क्या आएगा, ये V2, दिस इज द इंटरनल वोल्टेज E2 इनसाइड, and terminal पे you will get V2 and this is V1। So this is the no load equivalent circuit we have। Now if you see, you can diagram this। So IC equal to what, IC equal to क्या होगा, अगर I0 मालूम, phi 0 मालूम है, I0 cos phi 0, you can get IC equal to I0 cos phi 0, and I phi equal to कैसे निकालेंगे, I phi कैसे निकालेंगे, I0 sin phi 0, that is the active component of current, horizontal component or reactive component। So in this way you can find IC and I phi, clear। and how will you find RC, RC equal to you, it will require RC equal to क्या होता है, V upon I, V कौन सा, V1, यहाँ का वोल्टेज और दिस वोल्टेज will be same, voltage will be same, current क्या फ्लो हो रहा है, IC, V1 upon IC, we got IC from here, so you will get RC, exciting branch resistance, and XY equal to क्या होगा, XY equal to what, this resistance V1 upon ये current V1 upon I5 we got from here। So in this way you can find RC and XY also। So these are the components, okay। and core loss क्या होता है, voltage into करंट, वोल्टेज कौन सा है, V1 into IC, V1 into IC. So in this way you can find these resistance and reactance, currents IC and I5, and IC and I5 का वेक्टर सम IC स्क्वायर प्लस I5 स्क्वायर अंडर रूट ऑफ दैट क्या कहलाएगा, ये I0. Okay, so in this way you can find all these values. That is called as equivalent circuit of transformer at no load. That is a actual transformer. Okay, so whenever we will draw the equivalent circuit of active transformer or practical transformer at load condition, so this will be added. Okay, so this part is there, I have discussed only to clear your concept. Okay, so I am rubbing it. And one more thing I want to tell you, you can find reactance resistance on the primary side, secondary side, like that. मान लो आपने एक और चीज में I want to tell you here, आपको मालूम है Z01 क्या होगा, Z01, और सपोज करो प्राइमरी साइड हाई वोल्टेज वाइंडिंग है, तो Z0H इक्वल टू क्या होगा, R0H स्क्वायर ऑफ दैट प्लस X0H स्क्वायर ऑफ दैट एंड अंडर रूट ऑफ दैट, लाइक दिस. सो यू R0H क्या है मालूम आपको, R0H हमने अभी किया था, कितना बताया था, क्या बताया था आपको, R1 प्लस R2 अपॉन K स्क्वायर. X0H कैसे बताया था आपको, प्राइमरी साइड X1 plus X2 upon K square. In this way you will get this and this मालूम है, इसको अंडर रूट लेंगे, या Z01 1 है, Z0H इक्वल टू ऐसा भी ले सकते हैं, R0H प्लस J X0H. मैग्नीट्यूड निकालना है तो ऐसे निकाल सकते हैं, राइट. सो इन दिस वे Z02 निकालना है, दैट इज क्या करेंगे, Z02 मतलब Z0L कैसे करेंगे, ये सीधा डायरेक्टली Z0H मल्टीप्लाई बाई डायरेक्टली K स्क्वायर, ऐसे करो या सेपरेटली. R0H कैसे निकालेंगे, R0H सॉरी R0L मतलब R02 प्राइमरी सेकेंडरी साइड मान लो वोल्टेज वाइंडिंग है तो R02 लिखो, या R0L कैसे करेंगे भाई, सेकेंडरी साइड में R01 था, डायरेक्टली मल्टीप्लाई बाई K स्क्वायर, ऐसा कर सकते हैं, लाइक दैट. X0L or X02 equal to what, X01 into K square. So in this way you can transform secondary side also. Okay, so you can do it, no problem. I am stopping here. In future I will solve some problems based on that also, and it will clear your concept. Okay, so I am stopping here. Okay, thank you very much for listening me carefully. Thank you.